Hi everyone, this is Mahmouda Ayman and I'll be doing your tutorials for linear algebra this semester. So today we are going to talk about matrix multiplication and we're going to discuss some basic concepts about matrix multiplication and some properties of it. The first thing I want to talk to you about is when two matrices can be multiplied. So here we have two matrices. One is m times n and another one is n times p. And how do we know whether these two matrices can be multiplied? So this is the size of matrix A, let's say, and this is the size of matrix B. And can we multiply A times B or not? So how do we know that is we check here. So this is the number of rows in matrix A and this is the number of columns in matrix A. And so is here, this is the n is the number of rows and p is the number of columns. So if the number of columns of matrix A is equal to the number of rows of matrix B, if they both are equal, in that case we can multiply A times B here. So, and what would be the result matrix size then? The size of the, let's say, the size of the result matrix. The size of the result matrix will be, if you look at here again, so this one here, M, the rows of matrix A and the columns of matrix B, P, will be the size of the result matrix. So that would be M times P. Alright, now let's see some examples. So let's see, here I'll give you some matrices like A and B, and we'll discuss whether they can be multiplied or not. So let me write a question maybe. So let's say the question is it possible to multiply A dot B? So the first example here, let's say A is A11 and A12, A21, so these are the positions, A22, and we have the matrix B, which is B11, B12, and then we have B21, B22. So let's now write down the sizes of this matrix here. So this one here we have two rows, one row, two row, so two rows times the column, we have one column and two columns, so two rows and two columns. And here we have again the same, we have two rows and two columns, so that would be again two rows times two columns, the size of these matrices. So what we check now is whether these two numbers here, are they equal? Or maybe just I do it with another color so it's more visible or more clear to understand. So are these two equal? Yes, they are equal. So in that case, this matrix multiplication is possible. So you can say here A dot B is possible. And what would be the size of the result matrix. Let's say the size of the result matrix. So here, that would be this one here, the rows of matrix A times the columns of matrix B. So that's 2 times 2, the size of the result matrix here. Now, let's look at another example. So, a second example. And here the matrix A is 2, 3, 4, 5, and the matrix B is 2, 7, 10, 8, 5, 0, 1, 8. So what would be the size of this matrix here? Which, okay, let's say that's A. That's matrix. Okay, that's not visible. So this is matrix A and this is matrix B. What would be the size of matrix A? So we have here 2 rows. As you can see, we have 2 rows and 2 columns. So that's 2 rows times 2 columns. And here for the size of B, we have again 2 rows. So we have here 2 rows times columns. That's, sorry for that. So the number of columns is 1, 2, 3, and 4. So we have 4 columns here. So that's 4 columns. Now what we check is whether these 2 numbers here are equal. Okay, here we have a B in between, so ignore that or just erase those now for the time being. Okay, so are they equal? They are 2 and 2. Yes, they are equal. So here the matrix multiplication of these 2 is possible. So you can say A times B is possible. Now, again, the result matrix size. So what would be the result matrix size? That means, what I mean by the result matrix is that when you multiply these 2 matrices, you get a result matrix, right? The answer, when you multiply these 2, you get an answer, or you can say another matrix, which is your result matrix. What would be the size of this matrix here? So the size of this matrix will be multiplication of this one here and this one here, the leftovers, right? So the rows of matrix A, which is 2, times the columns of matrix B, which is 4. So this result matrix will be a 2 times 4 matrix. Okay, I hope it's getting clear. And then now let's do one more example. A third example. So let's say we have matrix A, which is 2, 3, 5, 8, and matrix B, which is 1, 0, 0, no, 1, 0. And then we have here 2, 2, 2, 1, 3, 5, 8, 6 here, and 9, 2, 0, 1. So now again, the size of this matrix here, matrix A, let's say, the size is, we have 1 row, so 1 times, we have how many columns here? 1, 2, 3, 4 columns. So that's 1 times 4 matrix. And here we have how many rows? 1, 2, 3, 4 rows. So we have 4 rows times how many columns? 1, 2, 3, 4. So this is a 4 by 4 matrix. Now what we check again is this part here, right? The last number here and the first number to the next matrix. If they both are equal, then this matrix multiplication is possible. So you can say here again that A times B is possible. And again, I would like to know what would be the size of the result matrix. So the size of the result matrix here will be these numbers again. So the leftovers, the rows of the first matrix, which is 1, times the columns of the next matrix, which is 4. So this will be a 1 times 4 matrix, the result matrix. Now we'll do a fourth and last example for this part. So here we have matrix A, which is 2, 3, 5, 2, 8, 9 times we have 8, 10, 2, 9, 11, 7, 0, 1, 2, 1. So now let's write down the sizes of these matrices here. So this one here is how many rows we have? 1 row, 2 row, 3 row. So 3 row times how many columns? 1 column, 2 column. So this is a 3 by 2 matrix. And here we have 1 row, 2 row, and 3 rows here times 1 column, 2 column, and the third column. So it's a 3 by 3 matrix. And now we check that whether the columns of the first matrix is equal to the rows of the second matrix. Is 2 equal to 3? No, it's not. They are not equal. So if they're not equal, then here A times B, the multiplication is not possible. Right? And if it's not possible, of course, we don't have a result matrix, so we don't need to write the size of that matrix.